This is question 7 and 8 of USNCO 2024 locals. So starting with 7, which apparatus would be most suitable for collecting a sample of solid barium sulfate produced through the reaction of aqueous solutions of barium hydroxide and sulfuric acid? Okay, so let's run through these answers. A is a barometer, which is honestly probably the easiest to cross out because barometer looks like that, and we have a little thingy here. So for barometer, this measures pressure, right? The pressure of some gas, and we're dealing with aqueous solutions and a solid here, everything that is literally not a gas. So A would be wrong. We want to B, a beaker. So I guess a beaker would look like this. It's a bad drawing, but yeah, so beaker, and then we have our solutions. And I guess the solid would just powder at the bottom. It's kind of hard to collect only the sample of sodium barium sulfate without screening your results, but I guess it might be possible, but it's probably not the answer. So that's not it. C is going to be a Buchner funnel, which might have done in some labs, but what it looks like is you have a little funnel here. So in this funnel, we have a thing, and that's going to go out with that. I think that's for like some pressure or something. I don't really know. But what's in this funnel, there's going to be a little tray here or something, and it's going to have a bunch of holes in it. So essentially what these holes do is that the aqueous solution, or whatever solution, goes down, and you'll be left with the solid right inside here. So yeah, solid being there, and yeah, it would just stay on top while the solutions go down. So this would pretty accurately collect our solid barium sulfate. So it's going to be check, and I'm just going to run through the Bure. So Bure would not be right, because think about it, it's for like taking solutions up, right? It's a collect volume, so it's not going to be collecting the solid barium sulfate. Probably going to do so really terribly. So this is going to be wrong. So our answer is going to be C. So let me just give myself some more space here. Okay. Number 8, a solution prepared by dissolving 10 grams of salt in 90 grams of water. What additional information is needed to calculate the molarity of the solution? Okay. 1, the molar mass of the salt, and 2, the density of the solution. Okay, so first we need to understand how do we get to the molarity, right? So molarity, I think it's M. That's equal to what? Moles of solute over liters of solvent. Also, no, this is not solvent. Solute over liters of solution. I don't know why I said solvent. Alright, so we're going to need the moles of the solute and liters, so it's going to be volume, and that's going to be N, right? So if we went to 1, it says that we need the molar mass of the salt. So let's look at that. So this is the molar mass of whatever is salt, and that, to get to the molar mass, we're going to need first the N, which is going to be the moles of whatever salt, and then you're going to need the M, which is the mass of salt, which you're actually already given here, 10 grams. So if we did, have the molar mass, then we'd be able to find the moles of salt and plug that in here, because the moles of salt is going to be the moles of solute. But there is one problem, because this won't allow us to calculate the molarity. We don't have the volume, the liters of solution. So we know we're going to need something else. And look at the answer options. You know that this is like not going to be A or B. But it does work, I guess. Which means that it's either going to be 1 and 2 together, or you just can't find it. So, number 2, the density of the solution. Again, this is like just something conceptual here. So, density. I think density is like mass over volume. Yeah. So, mass, volume, yeah. I think it's pretty obvious here. Mass of this solution, the volume, which is what we need actually for our polarity. So if we're given the density, we know the mass, which is going to be 10 plus 90 to 100 grams of solution. So we can easily find the volume, and that would be our liters of solution. So C must be the correct answer. See ya.